Well, thanks for having me. And hello, everyone. Today, I'll be talking to you about web payments, or more specifically, how to start accepting payments natively in your browser through a new API called the PaymentRequest API. But before we even get there, a bit about me, right? So my name is Krystian. I'm a payments tech lead at a company called Shopify. And what we do at Shopify is make commerce better for everyone, either by allowing our merchant to have an online presence through an online store, or having, say, a point of sale system in their already existing brick and mortar store. I'm also part of the Web Payments Working Group as a member of the W3C. And you can find me on most social media under the Krystian handle name. So that's a bit about me. Let's move on a bit to looking at the history of payments and checkouts on the web. So brief history. When the web first started with the HTTP spec, it first started with HTTP 0.9, created by Tim Berners-Lee, then transitioned to 1.0, 1.1, et cetera, and 2 as we know it today. But at the very beginning, there was no mention of status codes for payment processing. Well, there was one, right? And that status code was 402 payment required. And it's interesting because it's the only one that mentions payments in its name and is supposed to be used for payments. But if you look at the description, this is the interesting part, right? So if you read closely, it's reserved for future use, but not currently used. And that's quite interesting because you can see that the people that created the HTTP spec at the very beginning and thought of this status code knew that payments and commerce would be a thing eventually in the web, but still didn't know what that meant. So they created this status code hoping it'll eventually pan out. Sadly, it's not very used right now on the web, but that's not too bad, right? Continuing on, and fast-forwarding to today, as of recently, there was still no native solution to initiate a transfer of money on the web. And this is not to say that it's not been tried before. There were actually some solutions attempted in the past. If we go back to the 2000s, the W3C actually tried to push a spec called, let me read my notes, the common markup for micropayment per fee links. Quite a mouthful. And the spec was meant to provide an extensible way to embed some information on the page, so everything is necessary and available to initiate a micropayment. Now, for those who don't know, a micropayment is a transfer of money around $1 or less, and it was thought to be the future of the web in around the 2000s. It never caught on, and it was meant to either allow people to consume media or text, etc. But if you think about it, we have an equivalent now on our devices, right? If you go on your app store, you usually pay around $1, maybe more, for your apps. So it never caught on the web, but it's still catching on app stores. Before we move on to the next kind of iteration of a spec of payments on the web, let's just soak in what could have been the future of payments on the web. So this was the solution the W3C proposed back in the day. It was either initiated through an object tag, an applet, or an embed. And you had to provide all of those params to it. And yes, you can see it pointed to a Java class or a Java applet. So returning back to the history, right? This was the first kind of attempt of payments on the web back in 2000. Then we had something in 2005 called the Electronic Commerce Modeling Language. And this was initiated as a spec from a consortium of different corporations. These corporations included Dell, IBM, Microsoft, Visa, MasterCard, et cetera. And their approach to it was to expedite the online processing of a buyer's journey by simplifying the form filling procedure. So think of it as the early days of autofill we know today, but just for the payments part. Again, never really caught on. So all we have left today is, well, third-party payment libraries, right? If you think of the buy buttons you usually see, like PayPal, Amazon, Google Pay, Apple Pay, that's usually what we have to use to expedite the process of payments and accept payments easily on a merchant's website. Now, if you look at the state of the checkout today, well, sadly, it has now changed for a while. From the inception of commerce on the web, it's the same exact process that you have to do over and over again. It's the same tedious process of filling out form fields on different websites. And all those websites try to solve the same problems in different ways. And there are a few redeeming features, as we mentioned earlier, for helping to reduce the friction of that purchase experience, right? So we have things like autofill, the buy buttons we mentioned previously, and platform-specific solutions like customer accounts. But again, there's no native way of accepting payments on the web. Compared to that, you have statistics like 69% of people that initiated a checkout process actually abandon it. 27% of those abandon it because it's a too tedious process. And on average, you have around 14 fields that you have to fill out in order to get your goods, which is kind of absurd, right? And this is where Web Payments comes in. So Web Payments is actually a working group at the W3C, and their goal is to make payments easier, faster, and secure on the web. Now, it's comprised of more than 60 organizations. Shopify is one of them. And their very first mandate was what we call the PaymentRequest API. And here's a preview of what PaymentRequest looks like in practice. We'll get there. There you go. So as a buyer, I click on checkout. It's an unbranded experience, and there you go. You have your PaymentRequest sheet that pops up. The user then selects a shipping address that might be pre-filled from user agent-specific information. And it allows the merchant to leverage their own payment methods through their UI. Once the user has selected a shipping method, he now selects a payment method, in this case, a credit card. And then he's able to pay right away, confirming his CVC for extra security. And he's pretty much done, right? You have a bit of a waiting time, just the time to process the payment in the back end. And hopefully, you should have the thank you page of the user right here. So beyond this, as you might have surmised, right, this demo has been done on Chrome Mobile. But imagine this kind of process being a unified process across browsers. And I'm happy to say that today, there's a few browsers that now support PaymentRequest API, including Edge, Samsung Internet, Safari, and even Firefox. They're building it in their nightly version, but soon to be built in Firefox proper. And that's quite exciting. So what is PaymentRequest? Well, it's a checkout experience leveraged by some JavaScript API. It's directly in the browser, so you don't need to load any SDK. No need to wait for loading times. As soon as the page is parsed and loaded, you have access to PaymentRequest. And it can show multiple payment methods. But the most important thing that you have to remember of PaymentRequest is it doesn't actually process the payment. So this is to say that it gives you back the information that you have to then use to either process a payment or complete a payment. But it does not process the payment in the browser. And it's meant as an unbranded experience. So if you think back, when I click on checkout, there was no mention of PaymentRequest popping up. It's meant to replace the checkout as we know it today. All right, so how can I start leveraging PaymentRequest on my website today? Well, there's three main parts, right? There's actually initializing PaymentRequest, listening to a few events, and then actually showing the PaymentRequest sheet and resolving whatever it gives you back. So on the subject of initializing PaymentRequest, you have three params that you have to pass in. Let's skip method data for now and concentrate on details. So for details, you have something like this: display items and total. Those display items are not mandatory, whereas total is. And this equates to something like this in the sheet, right? So think of it as the order summary receipt that you have to present to the user. Now, one interesting thing to note here is The total is not calculated by the sheet. It's up to you to present it correctly to the user and do the summation probably in your backend. And please, for the love of God, don't do the summation in JavaScript, because as we all know, 1.1 plus 1.3 in JavaScript equals, of course, very frustrating. So please keep it in the backend. All right, so we've gone through the details of PaymentRequest. How about the options? Well, you have 4 of them. You have request shipping, pair email, pair phone, and pair name. They're pretty self-explanatory. And if you look at if they're all set to true, you'll have something like this, a pretty standard checkout process. Now, if you set them all to false, all the user has to enter is their payment method, selected, and they're ready to pay. So think of it as a good use case for accepting donations, for example. Or if you set request shipping to false only, maybe you want to accept digital goods that don't usually accept shipping address or need a shipping address. So that's for options, but now let's go back to method data. That's probably the most interesting part of this all and the core payments part of it. So what is method data, right? Well, it defines how you can get paid, i.e. what are the possible payment methods that the merchant can present to the user and the user can pay with. And again, you can specify multiple payment methods. If we quickly look at the method data that you have to pass into PaymentRequest, it looks something like this. And the most interesting part here is the supported methods key, right? So you have basic card and a URL-based one on Molly Ideal. Now you have 2 choices for passing in the string here. Those are called payment method identifier, and they can either be standardized or URL-based. Now think of standardized as a payment method that has been accepted in the W3C consortium and that the browsers can implement in a unified way in the browser. As for the URL-based one, think of it as a custom one that the user can install and then a merchant can leverage in PaymentRequest. Now, if you look closely at basic card here, and basic card essentially means I want to accept a credit card or accept credit card payment processing. Even if you pass in supported methods as basic card and it's the only option you pass in, it'll actually equate to 2 payment methods that the user can select. In this case, a credit card directly stored in the browser and something called Pay with Bob Pay, which is an example payment method that we've created. Now, why that is think of the left part of the screen, so the supported method, as what the merchant supports as payment methods, and the right of it as all the instruments I can use to actually give back that payload. So you can have multiple instruments, multiple payment methods that actually give back the basic card payload. In this case, we have the direct credit card, and then Bob Pay that will give back the same payload to PaymentRequest. So that's for method data and actually initializing PaymentRequest. How about listening to some events? Well, for the sake of time, I'll kind of quickly glance through it, but you have 2 events on PaymentRequest, shipping option change and shipping address change. And for example, for shipping option change, that gets triggered when obviously the user selects the shipping option. You get back the shipping option. It's up to you to update whatever resource you have in your JavaScript or your backend. And then it's up to you to also update PaymentRequest with the correct display items to display to the user. So let's say your shipping costs $5. It's up to you to update the PaymentRequest UI to now show shipping $5. And probably the most interesting part now is showing PaymentRequest. So in this case, we call the show method on the instance. And this gives us back a promise. When that promise resolves, you get back a payment response. And now this is where things get interesting. It's up to you to determine what's the method that the user has selected, in this case, basic card. And let's say we have a method called process credit card. Again, this method is something in our domain logic on our application level. It's not provided by PaymentRequest. And it allows us to process a credit card, so charge it, authorize it, whatever. You take the details of the payment response, you pass it to your method, and for example, our method will return us an order with a status of success, fail, whatever. Then at this point, the sheet is still open. It's processing, but it's up to you to close it down. And the way to do it is called the complete method on payment response, with either success, fail, or unknown. This will close the sheet and allow you to probably redirect the user to the thank you page. So this is where the complete method would do exactly this. And that's a quick overview of how you can leverage PaymentRequest on your website today. So as a summary, what is PaymentRequest? Well, it's a checkout experience leveraged by some JavaScript API. It's directly in the browser with no SDK required. It can show multiple payment methods, but very important, it is not a payment processor. And it's meant to be an unbranded experience. Now, this kind of technology, this kind of specification is quite exciting. Actually, we've been trying it out at Shopify, and we've seen some promising results when trying it with our merchants. But up until now, we've mostly been concentrating on the credit card world through PaymentRequest. So what if we now took a look at accepting multiple payment methods through PaymentRequest as payments on the web? So to do this, what we'll do is actually code our very own payment web app and accept payments through said payment web app. OK, we skipped the GIF. That's fine. So we'll do this through another specification called the Payment Handler API. And what Payment Handler API is, whereas PaymentRequest is a checkout experience that is agnostic of the payment method used, Payment Handler API defines how payment web apps can handle requests from PaymentRequest. Then these payment methods can be made available through the PaymentRequest UI. But let's take a step back first and think of why Payment Handler API is necessary at all. To do so, let's take a look at the breakdown of payment methods currently implemented in browsers through PaymentRequest. So if you quickly look at it, you have things like Basic Card, which we already covered, things like Google Pay, Samsung Pay, Apple Pay, something called Interledger, which we won't tackle in this talk. Now, if you think about it, all of those are credit card-centric. And it makes sense. As the W3C tries to push adoption of this technology, they first implemented what they know best, which is the credit card world, which is mostly the North American way of thinking, right? But then if you go international, if you go global, credit card doesn't necessarily make sense, right? You have things like bank transfers or ACH that are very popular in the United States. You have things like Boleto, SurveyPag, or Dinero Mail, which is a very synchronous way of paying. Cash on delivery, which is very popular still in India. And things like what we already covered, wallets like Alipay, PayPal, Amazon, etc. Now, this is where Payment Handler API allows us to ourselves code our very own payment method and show it to the users through PaymentRequest. So we don't have to wait on the browsers to implement the payment methods themselves. Sadly, it's only available on Chrome right now, but as adoption grows, browsers will slowly implement it themselves. So what does Payment Handler look like? Well, let's say we have this awesome new payment method called Christos Coin. The user will first visit that website and install it on their browser. So think of it as going to a wallet like PayPal and Amazon, registering, and then in the background, in this case, and we're skipping ahead, in the background, in this case, the payment method gets installed in your browser. So you click install, it's installing, and then eventually you'd have installed. There you go. So now when the user visits a shop, let's say the Kafivi shop, which sells coffee, and he clicks on checkout, well, he goes through the usual process of selecting shipping address, shipping method, but they'll then have the option of selecting their favorite payment method, which is pay with Christos Coin, which they'll do exactly here. They've selected payment method, ensure their order summary is correct, click pay, and what happens is you get redirected to the checkout of Christos Coin. You have the total here. Click pay to initiate payment processing, and you're done. You're on the thank you page. So how do we go about actually implementing a payment web app? Well, there's 4 main steps. Setting up said payment web app, then registering it to the browser, surfacing the payment method in PaymentRequest, and then finally allowing for the request of PaymentRequest to go through the payment method. All right. So if we go back to the example of the Christos Coin website, we'd have 3 main files that are interesting in this case. payment manifest, and then manifest and service worker. The two last ones should be familiar for people that are developing progressive web apps, because payment web apps are exactly that. There are sugar-coated PWAs with a payment manifest.json. I'm not here to talk about exactly how PWAs work. Zach will probably do a much better job in the next talk afterwards. But suffice it to say that it has a payment manifest, and a service worker. Then we have three routes. The install page, which in our case is on our root of the domain, and a payment method identifier URL, which is on /pay. It never gets shown to the user, but it's used to identify the payment method. And then finally, we have our checkout page, which we've seen previously. Now, for the payment method entry point, as we said, we have this /pay route that has no content. It gives us back a header, a link header of pointing to the payment method manifest. So in this case, on payment method manifest.json. Now, what this manifest contains is two keys: default applications and supported origins. All default application says is, here is where my payment web apps are located. And think of supported origins as a way for third-party payment apps to actually start using my payment method. So let's say Krystian becomes really popular and PayPal wants to start using it. I have to explicitly either put it in supported origins or actually just put star so that anyone can start using it. How about registering the app? So we've seen in the demo how a user goes about installing the app. But what actually happens in the code? Well, so once I visit here and click install, I need to first install the service worker. Then once the service worker installed, which might be familiar to you, you actually add it as an instrument to what we call the payment manager. And the way you do that is you specify a unique ID, a name, and then enable methods, which is our /pay route we've seen previously. Now it's up to the merchant to go back to their method data, and they can start accepting Krystian by just adding it as a support method in PaymentRequest as such. So that's great. Now we have also a manifest.json. This contains a name, a short name. Again, it should be familiar for those developing PWAs. And now we have the root of our logic for accepting a payment through our payment method. That's done through the service worker. We'll have two parts to the service worker. We'll have an event that we listen that is called the PaymentRequest event, and then a message event that will go into details afterwards. So we have this event listener on PaymentRequest, and this actually gets triggered when the user clicks pay in the PaymentRequest UI as such. There you go. Once that gets triggered, the PaymentRequest UI changes to a pending state. And it's up to you to resolve that pending state. Now, to be able to do that, first what we want to do is just keep in memory the event we got back. I'll get into details why afterwards. And then create something we call the resolver. Think of a resolver as an interface to control the state and the result value of a promise. So on a promise resolver, you could access the underlying promise and then call methods like reject and resolve on the promise resolver. Then what you want to do is call respond with to the event with the unresolved promise. And this is where it's up to you now to resolve that promise. And the way to do this is we want to redirect the user to the checkout page so we can process the payment and then finally close the window. And the way to do this is we call open window on event with the /checkout URL we had in the demo. At this point, what you want to do is establish a two-way communication between the checkout page and the service worker. And the best way to do this is through post message. So let's say you're on your checkout page. You'd first have an event listener on message to be able to listen to post messages coming from the service worker. And then right away, you send back a message through post message to the service worker saying, I'm ready. Once this is done, there's also an event listener on message in the service worker. And they're now able to communicate between them back and forth. So the event listener of message gets triggered. We get into the ready conditional. Now we have some boilerplate to just communicate back to the checkout page by getting the client list. And then finally, we can post back a message of, in this case, the total we received from PaymentRequest. So now going back to the checkout page, the message event listener gets triggered. We keep the payment details in memory for later on for processing. And then we show the total. So the user can actually see the total on their page as such. And once the user is ready to pay, we can actually process the payment. And again, it's not the job of PaymentRequest to process the payment. It's up to you to process the payment through your usual infrastructure. And then in this case, we have, say, a pay method that gives you back order details. So say a transaction ID, timestamp, etc. Once you're done with that, you have to just signify back to the service worker that you're done. The way to do this is, again, posting back a message to the service worker with, say, name pay and some payment method data, the details of the order and the method name. And what that does is go back to the service worker. The pay conditional gets triggered in the message event listener. And then this is where we kept the resolve in memory. You actually resolve the promise because you're underlying the checkout page, there's still the pending state on PaymentRequest. And you pass back the payment method data. And this is where the resolver gets resolved. Sorry, the underlying promise in the resolver gets resolved. And PaymentRequest.show also gets resolved. Then you get payment response back as per usual. And rather than the user selecting basic card or something that gives you back basic card, well, you now check for the method name Krystian/pay, and you process Krystian however you want to do this. Remember, the processing in this case has been done on the Krystian checkout page. So all you want to do probably here is reconcile your order transaction or some orders so you can have, say, a unified ledger in your system. From this, you get back an order still, and then you're able to complete the payment response, which actually closes the sheet of PaymentRequest, and then redirect back the user to the thank you page. And that's how you actually create a payment web app through Payment Handler API. So as a summary, what is Payment Handler API? Well, it allows us to surface our very own payment method. It standardizes the payment method communication between PaymentRequest and your payment method. And it allows for registration of third-party payment methods. And one of the advantages of Payment Handler API is that it's just JavaScript. So if you're actually processing a payment, like again, PayPal, Amazon, or any kind of payment processor right now, you can just sprinkle some lightweight JavaScript, create a payment web app, and start accepting payments through PaymentRequest fairly fast. Now let's summarize what we've learned up until now. The checkout has not changed for the longest time. And this is where PaymentRequest brings the checkout process, or the checkout experience, to some of the major browsers in an unbranded fashion. Finally, we have Payment Handler API that allows for custom payment methods to be surfaced. Now, it does come with some caveats, right? And those caveats can be categorized into two kind of big categories, either payment affecting or checkout affecting. Now, payment affecting can be stuff like, if you've seen the demo closely, PaymentRequest doesn't accept discount codes. It doesn't deal with tender transactions, which are split payments. It accepts very few payment methods, and this is where Payment Handler API kind of helps, but again, adoption is kind of slow. And then you have caveats that are checkout affecting, such as accepting terms and conditions, KYC information, which is know your customer information like age, SSN for restricted goods, accepting delivery dates, subscribing to newsletters, etc. Of course, you can surface most of this, including discount codes, before PaymentRequest gets shown to the user. But that might not be the best user experience. So if you want to start using PaymentRequest, just keep those caveats in mind. So as we've seen, there's actually beginning to be a paradigm shift as of today for web payments. Whereas before, merchants would accept payments and would allow for frictionless purchase experience through buy buttons like Google Pay and PayPal. Well, now you have payment method that accepts, payment request that accepts a bunch of payment methods, and the user actually has to explicitly install those for them to be surfaced in payment request. Whereas before, those buttons would get presented to the user no matter what. And these are only the few initiatives that the W3C is working on. They're also working on stuff like network tokenization and 3DS. Sadly, I don't have time to go into details on what those are. But I would actually invite you to join the discussion. So if you're interested in web payments or just payments in general, do visit their wiki page. They have a W3C web payments wiki page you can visit. That'll redirect you back to some GitHub repos for the payment request and payment handler APIs. There have been some very interesting discussions there. There's a web payments Slack. You can also join under the bit.ly/Let's Talk Web Payments. And if you're interested on knowing what we do with payment request at Shopify, what were the use cases we used it for, we actually did some bit of experimentation and published a few blogs on it. You can find them under the bit.ly/Shopify Web Payments link. And then we've also done some demos with the W3C that you can also visit here. If you're ever interested in talking also about web payments or payments in general, do come and see me at the break. We can talk about some of those topics I've talked about here. We can talk about cryptocurrency. We can talk about crashing drones, which is my specialty as well. Don't be shy. And I invite you to start using PaymentRequest and to finally kill the checkout as we know it forever. Thank you.
We have a couple of great questions online. I know we want to just keep moving so we can get everyone out to lunch, but I would like to ask the first one that was there, which I thought was most appropriate given the intro that I gave you. Somebody was saying that, when you're dealing with things like web payments and so on, there are certain environments in which having really tight customization for the purpose of the appearance, branding, and so on is super important. I think you touched on a little bit. Can you just give your thoughts on what's involved when you're making this user experience when you have very specific, tight requirements and you want to really customize it? Is that possible? Is it easy? What's the story?
So is the question of how customizable is payment request? Is that it?
For the purpose of I'm building a website, and my client or my company has very specific, not necessarily standard requirements for how we want to brand it, frame it, do its appearance. How customizable is that user experience?
Yeah, so that's a very good question. It's actually not very customizable. All you can really customize is the fav icon or the icon you'd see on the top left. And it's actually an interesting question we've been tackling at Shopify as well, because we do allow our merchants to slightly customize their checkout. And with this kind of experience, you can't really customize it. Now, what we think is having a unified process will kind of trump those concerns of customizing the checkout process, but we're still unsure, so it's something we're exploring with the W3C.
What's the biz speak word? It's evolving.
Correct.
All right. There are a few more questions. Will you check in on Slack and
Sure, of course.
answer them? Thank you very much.